This is the last two examples on the 7-3 Day 4 notes. The final two techniques for integration by parts are things that can happen that you might want to consider. So yesterday, or when you last were doing things, we ran into a time when we could keep going and going and going with certain terms and having them show up needing tabular integration. Today we're going to come up with ones where we could end up in an endless loop if we kept going with integration by parts, and we're going to show you then how do we get out of that endless loop. So in looking at the integral that's given to you, and actually this is a differential equation, so as we move this one around, here's what we know. We know that dy then should be e to the x cosine x dx, moving that differential over. And so we know what we're really looking for then is we're looking for that the y is equal to whatever the integral of e to the x cosine of x is. So as we go to take that apart by parts, I want you to keep in mind what that y function actually is, what a y is worth or what it's exchangeable for, because we're going to see the original problem come up again in our work. So as we go to take this one apart by parts to do the initial integration, I would go through Liate, and I would pick as my u, I would pick trig, because it's the first thing in the list that I have in my expression, and then I'd pick my dv to be that e to the x dx. Well, cosine as a u means that my du is going to be the opposite of sine. And as I go through and do my v then, what I'm realizing is that my v is going to remain e to the x. And that my u and du are going to flip back and forth between sine and cosine all the time. So I'm going to keep getting a need for integration by parts. So as I start to work this through, I'm going to put on this side y equals. And then as I start to take apart that integral using my u times v, so e to the x cosine x, doing my u times my v, and then my v du is going to be minus the opposite of those two multiplied together. I left out my dx. Okay, minus the two of them multiplied together. So I'm going to end up with plus e to the x sine x's integral. Okay. And when I get there, I'm thinking, okay, I now have another integral here that I need to take apart by parts. So I need to pick, again, another u and a dv in order to take this one apart. But what I'm starting to recognize is that I could get trapped in kind of an endless cycle here. So if I make this my sine of x term, and then I go ahead and I take my dv to be my e to the x dx, I see that I'm going to end up kind of in a similar place. My du is going to be cosine of x dx. My v over here is going to be the integral of e to the x, which is e to the x. So when I go to put this together and evaluate this, you have e to the x cosine x plus everything that comes out of this integral. And this integral is going to be my new u times my uv minus, and now my new integral. But my new integral should look really familiar. My new integral is the original problem we were tasked with finding the integral for to begin with. This is exactly what we started with. And so if we continued to go through, we would just keep cycling back and forth. So instead, what I'm going to do is, for the moment, I'm going to replace that expression with the fact that I used to call that expression, and I have these two still. Instead of that integral, come back up here for a minute. That is my y. That is the expression I was trying to find in the first place. In other words, it shows up as we start to try to evaluate its own integral. So in algebra, you would just add that y to the other side. So on this side, I have twice the integral that I'm looking for is e to the x cosine x plus e to the x sine x. So if that's twice the integral that I'm looking for, then one of the integral that I'm looking for, which again is that original integral of e to the x cosine x dx, what I was supposed to be finding in the first place, would be to divide what I have here in half. So I would divide both sides of this expression by 2, divide all that by 2. So the y I seek, which this was my initial problem, should be equal to e to the x cosine x plus e to the x sine x divided by 2. So if you get into that cycle where you see your initial problem again, then you could do this, where you could substitute your initial problem for the y function that it was. We've got that right here. And then do some algebra so that we come up with what we were seeking in the first place, the y function, right? And of course, plus our constant, which could be up in the top or could be down in the bottom. It wouldn't really be a big deal, it'd be a different constant. And the last one, final technique, is if we have inverse trig functions. I said that I would provide you with some of those factual things about inverse trig functions derivatives and trig functions derivatives, but to integrate that, that's a little bit different. So they would like the integral of inverse sine of x dx. So as we're looking to do this, we know that inverse trig is one of the first things we suggest for by parts to take in Liate as logs, then inverse trig functions. So we're saying we would like to make inverse sine of x our u. Then our dv is either 1 dx or just the dx part, and that's okay. So then our u is sine inverse sine, so our derivative then is its derivative, and if you need to, look that back up, 1 over the square root of 1 minus x squared dx, and over here if dv is dx, then v is x. So as I go to put this back in here, I'm going to get that the integral of the inverse sine is my u times my v, x, inverse sine of x, minus, and then the integral of x times 1 over the square root of 1 minus x squared dx. When I start to imagine what's got to happen to my integral here now, I want to think about how I'm going to integrate that. Now I'm actually thinking substitution. I don't think I need to break that apart. They're both kind of algebraic expressions. And when I look, if I tried just a plain old u substitution of 1 minus x squared, got ahead of myself, then my du could be negative 2x dx, which I think I can get in there. Then I can integrate this. Ignore the bell. So I've got x inverse sine of x minus everything that's going to come out of this when I do this, but let me put everything in that I need. I see the x, but I don't see the negative or the 2. So I want to put a negative and a 2 in there in order to have everything I need to do u substitution. But then if I put in the negative and the 2, then out here I'd need to multiply on the outside by a negative 1/2. So that's what we're going to end up having. And as we start to work this through now, we'll be able to get our integral value with a little u substitution. Plus half, and now I'm going to go to my u substitution. That's all going to turn into my du. So I basically have 1 over u to the 1/2 du. Or you could put u to the negative 1/2 if you'd like. So integrating that, I know I've got 1/2 times, it was u to the negative 1/2 really, so I'm going to end up with 2u to the 1/2 as its integral, plus the constant, of course. So final on this one, using inverse trig as my, and then u to the 1/2 would be square root of what the u function was, plus a constant. So you should be able to finish those last two that are in the 7-3 day 4 homework.